So we've talked about how to recognize linear functions, and we talked about this idea of a constant rate of change. Another word for that is slope. Okay, slope represents the steepness of a line. Okay, so slope is that constant rate of change. And we're going to use the letter M to represent slope. All right, a new phrase that we didn't talk about in the last video is rise over run. All right, so to go from point to point, I'm going to apply that slope. So like if I start here, I'm going to rise. That's my change in y. So like if I go up 3, I'm going to run. So that's my change in x. I'm going to go to the right 4 to get to my next point. Okay, so this idea of slope, rise over run, change in y over change in x, that's going to be super big. Okay, there are 4 types of slopes that we're going to talk about. A positive slope, all right, so that would be the m is positive. All right, this would be an increasing function. If I'm on this line, I'm going up this line. It's increasing. So my m value is going to be positive. All right, I could have a negative slope, so the m is negative. And this would be a decreasing function. All right, I'm walking on this line and I'm going down. Okay, we could have a 0 slope. So for this, m equals 0. If I'm on this line, I'm just going at a constant. I'm not increasing or decreasing. This would just be constant. All right, kind of boring. We're just walking along that line, no change. We're not walking uphill or downhill. Okay, if your slope is 0, if I think about this, that would be y equals 0x plus b. If I'm doing the y equals mx plus b, which would mean this would cancel out, and so I would just get y equals b. Okay, so a horizontal line means that we'll be dealing with the equation y equals some number. All right, for example, here, this is y equals 5. Every point on this line, the x coordinates are changing, but your y coordinate stays 5. Okay? And then for this one, we could have an undefined slope. I already used that color. Get a new one. Undefined slope. This is not a function. Okay? Undefined slope. There is no slope. Okay? We are rising as much as we want, but we're not running at all. There is no change in x. All right? And notice everywhere on this line, the x coordinate stays the same. All right? So a vertical line means that we're going to have x equal to a number. All right? For this problem, it's x equals -5. So those are the 4 types of slopes. The first 3 are linear functions. An undefined slope is not a function. Okay, let's go to our first example. How do we use slope when trying to graph? So plot the given point on the coordinate plane and then use the slope to find at least 2 more points and then write the equation of the linear function. So the equation is y equals mx plus b. M is my slope. B is my y-intercept. Okay, so in this first one, our point is 2, 0, x comma y. So 2, 0, this is where I'm going to start. My slope is 3 over 2. All right, remember this is rise over run. So if I start at this point, I could go up 1, 2, 3, to the right 1, 2. I rise 2, I run 2. Okay? I could also go down 3 to the left 2. Down 1, 2, 3 to the left 2. And notice how there you have your y-intercept. Okay, so we have 2 points. We can keep going though. We can do this for infinitely long. We could go up 3 to the right 2, or down 3 to the left 2. Down 3 to the left 2. I could keep doing this in both directions until I get the line right here. I'm gonna make that become a line. There we go. That is the line. All right, so we have the slope. We have the y-intercept, which is right here. That's 0, -1, 2, 3. So the equation of this line is y equals my slope, which is 3 over 2x. So my slope is 3/2. So 3/2 x minus 3. Okay, we're given our slope and we're given our y-intercept there. Okay, what about in the second one? We start with this point, -8, 4. So x comma y. So I go -8, 4. 2, 3, 4. This is my point. My slope is -1/4. So I'm going to go down 1 to the right 4. Oh, that was only 3. Got to make sure we're counting correctly. Down 1 to the right, 1, 2, 3, 4. All right, because we went down, which is the negative direction, and then to the right, which is the positive direction. So we could look at this as either -1 over 4. We could go down 1 to the right 4. Or we could look at this as 1 over -4. Either way, that's going to give us a negative slope. So we could go down 1 to the right 4, or we could go up 1 to the left 4. But you notice how that's going to be off my graph. So I'm not going to include that point, just because I don't know exactly where it's going to be located. Okay, so I'm going to keep plotting some points. Down 1 to the right 4, down 1 to the right 4, down 1 to the right 4. Okay, and I'm going to connect the dots now to create my linear function. Notice how this is a decreasing linear function. In example 1a, that's an increasing. All right, the equation of this line, we've got our y-intercept right here, 0, 1, 2. So the equation of this line, y equals my slope, which is -1/4, okay, times x plus 2. All right, so that's this idea of slope, a rise over run. We start at a point and we apply that slope to get more points. That way we can graph a nice straight line that we can write the equation. In the next video, we will talk about how to calculate slope. How can we actually use a formula to calculate slope?